Hello students, today we are going to study about equations of motion and we will derive them using graphical method. First, what are the equations of motion? The first equation is V is equal to U plus AT, and the second equation is S is equal to UT plus half AT square. And the third equation is V square minus U square is equal to 2AS. Now we need to, earlier using analytical method, we derived the equation. But now we are going to derive it using graphical method. We are going to take a velocity time graph for that. Now let me draw a velocity time graph. See, the y-axis has velocity. Okay, velocity, and I express velocity in meter per second. Fine. And in the x-axis, let me take time. This is time axis. Time we will measure in seconds, and this is the origin. Okay. So when we study about a graph, a body in motion, the body is not starting from origin. It has already some initial velocity. I observe a car moving, right? It has an initial velocity. Let us say 20 meters per second. Fine. So I will have a minimum value here. This is the initial velocity U. And it is a constant acceleration. Okay. So you will find that the graph will be a sloped straight line like this. Right. Okay. Now what is this? Maximum value. Fine. The maximum velocity. So let me draw again dotted line to know that this is the value, final velocity V. With this graph, we already studied that the slope of the graph of velocity time graph will give us acceleration. Okay. So acceleration is equal to slope of the straight line AB. Fine. Slope of straight line AB. How do we calculate the slope? So let us say this is point A and this is point B. We need to calculate the slope. So let me draw a normal. Okay. I drawn a normal now. And this is the point here. It is not from 0. So I draw a x-axis value. That means parallel to the x-axis value. Let us say this point is C. You see the right angular triangle ABC. Now I need to find the slope of this graph. Right. Let us write here. That is equal to, slope is y value upon x value, which is equal to, what is the y value? BC divided by, what is the x value? That is AC, which is equal to AC. That is equal to. Now what is BC? There is no value here. Value is lying here in the axis. So let us call this point as D and this point as E. Now BC is nothing but AD. Okay. So AD divided by, what is AC? AC is nothing but OE, which is representing time. So OE. So acceleration is equal to, what is AD? AD. D is the final velocity and A represents initial velocity. So the difference between these two, V minus U, right? V minus U divided by, what is OE? OE is x-axis, time. So that is time. Take the T up. So you get AT is equal to V minus U, or V minus U is equal to AT, or V is equal to U plus AT. So we have derived the first equation of motion. I hope you understand now. So using the slope, we calculated the acceleration and we found the first equation of motion. Right. This is done. Now second equation. What the second equation talks about? It talks about the distance covered. Okay. Let me erase this part now. Fine. Distance covered. What does the velocity time graph talks about distance? We say distance covered is equal to area under AB. Area under AB. Now the whole thing is there. I divide it into two parts for my convenience. Let us say it consists of a rectangle with a length and a breadth, and I got a triangle, a right angled triangle. Okay, now we know the area, individually add them up. Fine. So area of rectangle, what is the rectangle we have taken? OACE plus area of triangle. Which is the triangle we have taken? ABC. Area of the triangle ABC. Which is equal to, what is the length of the rectangle? The area of the rectangle, length into breadth, plus that of the triangle, half base into height. That is equal to. Convert it into the symbols here. Length is OE and breadth is OA. So we can write OE multiplied by OA, close the bracket, plus half into breadth. What is the breadth of it? AC, right? AC multiplied by, what is the height? Height is nothing but BC. Fine, BC. Let us go slow, right? We will take extra step, but we will not make mistake. Fine, into OA plus half into AC. Once again come here, AC. AC is OE and BC is AD. Okay, OE multiplied by AD. Fine. You got this much now? So let me erase this part now. Distance covered. This much I have done already. I am going to just to make substitution. Distance covered is S is equal to OE into OA. OE represents the time and OA represents the initial velocity. Okay. So T into U plus half into, again OE is the time, multiplied by AD. This is what we are concerned. Again AD or DA is nothing but V minus U, right? So now let us write here V minus U. Fine. That is equal to UT plus half into T into, yes. Now we have to substitute somewhere for the value of time, let us say. What is the formula? Or V minus U, let us say. We know V is equal to U plus AT, or we know V minus U is equal to AT. So can I put V minus U that is equal to AT? Fine. Now I put that is AT, and that is equal to UT plus half AT square. That is equal to S. And what is this? This is second equation of motion. This is the second equation of motion, and we have derived it using graphical method. Last equation is also having distance in it, right? So again we go back to the same point, that distance covered from the graph of velocity time graph, distance covered can be said to be the area under AB, the straight line, that is equal to. Now already we took rectangle and triangle. Here we will take the whole shape. What is the whole shape? You see carefully, it is nothing but a trapezium. The whole thing is nothing but a trapezium, right? Now see what, now how the trapezium is. It has got two parallel sides and it has got a height. It is really in this form. Fine. It is like this. Two parallel sides are there, A and B, and it has got a height. Now we need to calculate the area of the trapezium. That is area of the trapezium. What is the trapezium? OABE. OABE. which is equal to, what is the formula for area of a trapezium? Half into sum of the parallel sides multiplied by height. That is equal to half into, what are the two parallel sides here? One is this, another is this. Okay, OA and BE. OA plus BE multiplied by height. For this, you invert like this. Height is AC or OE, we can say. Let me say OE. That is equal to half into, what is OA? OA, it is nothing but initial velocity U. And what is BE? The whole BE, it is final velocity. So I got U plus V multiplied by, what is OE? Which is the time axis T. Now, having done this, what we do? We erase this, let us erase it. Fine, take the final value and make substitutions, right? That is equal to half into U plus V. A plus B is equal to B plus A. 1 plus 2 is equal to 2 plus 1. So, V plus U multiplied by T. Again, I come back to the same equation. From this, we can say T is equal to V minus U upon A. So, I am going to substitute this. You can again do it. Same, finding the slope, acceleration. We need not do that. We can take over this answer. Right. V minus U upon A. Fine. That is equal to half into A plus B into A minus B. A square minus B square. That is V square minus U square upon A. What is this? Distance covered. S. So S is equal to V square minus U square upon 2A. Take 2A up here. So you will get the formula 2AS is equal to V square minus U square, or V square minus U square is equal to 2AS. And this is the third equation of motion. So now we have derived the three equations of motion using graphical method, and velocity time graph we have taken, right? Analytical method also we have done. One more method is there, and that is calculus method. I feel you don't need it at this point of time, right? And we will have next video on the next topic on the motion. Thank you so much.